This is lesson 11.3, part 2. In this half of the lesson, we will learn how to determine events are mutually exclusive and then how to calculate their probabilities if it is an OR probability. So, mutually exclusive events are two events that cannot happen at the same time. So, for example, if we roll one standard number cube, can we roll a 2 and a 3 at the same time? So 2 would be an event and 3 would be an event. Can we get a 2 and a 3 on one die at the same time? The answer is no. So that means since we cannot get them at the same time, these events are mutually exclusive, which I will abbreviate as ME. B, rolling an even number and a multiple of 3. Can we get an even number that is also a multiple of 3? And the answer is yes. We can get a 6. 6 is even and a multiple of 3. So these events are not mutually exclusive. Example C, rolling an even number and rolling a prime. The number 2 is even and prime. So these events also are not mutually exclusive. D, rolling an even number and rolling a number less than 2. Now these events are mutually exclusive because the only number less than 2 is 1 and 1 is not even. So if events are mutually exclusive and we're doing an OR type of probability, then we will add the two probabilities together. Only if they're mutually exclusive will it be this simple formula. If the events are not mutually exclusive, we have to do this more complicated formula at the top. So let me show you how it works. Suppose a student can take one foreign language each semester. About 57% of the students take Spanish and 15% of the students take German. What is the probability that a student chosen at random is taking Spanish or German? So we're looking for probability of Spanish or German. Since they can only take one foreign language, these events are mutually exclusive. So we will just take the probability of Spanish plus the probability of German, and that will tell us the probability of Spanish or German. Probability of Spanish is 57%. Probability of German is 15%. So if we add those together, we would get 72%. On the bottom here, about 3% of students take Mandarin Chinese. So what's the probability that they will choose Spanish or German or Mandarin Chinese? Since they're ORs, we're just going to add them together. Spanish plus probability of German plus probability of Mandarin Chinese. So that'd be 0.57 plus 0.15 plus 0.03, which would give us 0.75. So these are all mutually exclusive. Okay, looking at this dish at the top, we have some shapes and some colors. So let's suppose we reach into the dish and select a token at random. What is the probability the token is round or green? If you look in the dish, we have some that are round and also green, so these are not mutually exclusive. So we have to use our longer formula. So it's going to be the probability of round plus the probability of green minus the probability that the thing is both round and green. So there are 5 round ones, and there are 3 green ones, and there are 2 that are both round and green. And altogether there are 9 items in the dish. So we would do the math like this. 8 minus 2 is 6, and that reduces to 2/3. So the probability we get round or green is 2 out of 3. Okay, the probability that token is square or red. Probability of square or red. Since some of the red ones are square, we have to do the longer formula again. Square plus red minus the squares that are red. They're both square and red. So 3 out of 9 are, no, it's the red ones. Squares. 3 out of 9 are square. 3 out of 9 are red. One of them is a red square. So that gives us 5/9 probability. Finally, and I'm going to leave you to do this one yourself, you can calculate the probability that's green or square by doing the same method. And that concludes lesson 11.3.